Okay, I'm hoping you've got more time than normal to do today's assignment. So this is the last one in Unit 6. We're going to be solving what look like formulas for a specified variable. So they'll give us a formula. They'll tell us, hey, solve for x, solve for y, solve for p, solve for q, whatever it happens to be. Okay. And on this one right here, just to review what we did yesterday, because this says less than 0, if we're going to graph this, we want this below, or could it be on? Could this be on the x-axis?
Yes.
Yeah.
This one?
What?
Oh, there we go. Is that better? This one right here? No, okay. So just below the x-axis. Okay, this one right here, once we're done graphing this is either, because it's greater than, this is above or below? Above, because the greater than. So above, can it be on? Okay, above or on the x-axis. Okay, so we want to sketch what this looks like. It looks like x squared. It's a regular old parabola, opens up. So I'll just put up right here. And we'd factor this. We're looking for two factors, two numbers that multiply to be positive 30 combined to be negative 11. Jack, you got those?
Yep.
What are they?
It's -5 and -6.
-5 and -6, which means we've got an x-intercept, a root, a 0 solution of 5 here and 6 here. So this is kind of a funky one. It just does this. And we want to know where it's strictly below the x-axis. So that would start at 5 and stop at 6. So this is 5 comma 6. And Abby, round or square around these? Round. Okay, so there's the answer. Okay, we don't have to be aware of any domain issues or anything like that because it's just a regular old parabola. We're literally graphing the right shape, so we're in good shape. So this right here, we want to change this behavior for something that's easy to graph. So I'm going to zoom in on this, and we're going to multiply by, there we go. We're going to multiply by x plus 4 quantity squared. So I'll multiply by x plus 4 quantity squared, x plus 4 quantity squared. Crew?
Why do we do like the quantity squared again? I forgot.
Okay, can somebody remind crew why we do the quantity squared? It has to do with how we solve inequalities. Why do we do that?
Because just in case the x is a negative, so it's not a negative.
Okay. If we're multiplying both sides of an equation by a variable, we don't know whether it's positive or negative, so we want to guarantee that it's positive. Okay.
Yeah.
So then we don't have to switch the direction.
Yeah.
So this is going to be a parabola that opens up. It's going to cross at, this one's -4, this one's +7. So we've got a -4 here, a +7 here. So it looks something like that. And we want to know where it's above or on, right?
Yep.
Keely.
Do we still have to do the thing that's like x can't equal the negative?
We do. And I'll do that at the end, but bring that up again. Okay, so if we were to write down the answer, where is this above or on? It's over here and over here. And again, we're not looking at the y coordinates. We're looking at where this happens. So we're looking at x coordinates. So this is going to be from -infinity all the way to, this was -4. We'll start up again at 7 and we'll go to +infinity. Always round around here. And because this is an equal to, we would think that those are going to be square brackets. But Keely, what was your question? Okay, we have to go back and we consider, we're not graphing the original function. We're graphing kind of a model that matches its behavior above and below and on the x-axis. The only thing is, these don't have exactly the same domain. So what we want to do is we want to throw out, there's one number that can't be included in the answer, and that's going to be -4. So we make one tiny adjustment to it. And D, what do we do? What do we fix on this? Make a round bracket on the -4. Perfect. So that right there is the answer. Okay, does anybody have any questions? Other than Mason? Just kidding, Mason. What's your question?
So, like, why does this work? Why does that, like, work?
Because what we're doing, so do you agree that algebraically we're multiplying both sides by a quantity that's always positive?
Yeah.
And would you agree that we're doing the same thing to both sides? Mm-hmm. So what we're doing is we're making a new function, this one right here.
Yep.
that matches the behavior of the original function whenever it's above or below or on the x-axis. Okay, that's all we're doing. Is we're doing a little algebraic trick to make it easier, which we do a lot of times. We change the way things look using substitutions and stuff like that. Okay?
Well, under the hood though, because like the -7 and the +4 are the zeros, and that's already in the original.
Okay.
equation.
Mason and I are going to chat after we're done with this lesson. Okay? All right. So we're going to take a look here. There are 5 problems I think that we're going to do, and then I'm going to hand out the assignment. These go relatively quick. You saw a little bit of this in 7th grade math, 8th grade math, secondary 1, and in this class we do it again. So we're going to use some algebraic rules, just like we were talking about a second ago. We're going to manipulate these things to look the way we want them to. Okay, and we're just going to take the instructions for granted. They're going to say, hey, I want you to take this formula right here, and I want you to solve for B. Now, the only caution to this is these are a bit more advanced than the ones that you did last year or the year before. And you want to be careful about the way you write your answer, especially if you know what the variables represent. If you don't, if it's just some random formula where you have no idea what they represent, we're just going to solve it and write down all the mathematical answers. You'll see what I mean in just a second. So on this one here, they want us to solve this for B. So when we solve an equation for B, what that means is we're going to get that B on one side all by itself. So we treat everything else as if it's a number. So if I want to get this by itself, the first thing I'm going to do is I'm going to get rid of the a squared. So Caleb, how could I move that a squared to the other side? Yeah, we're just going to subtract a squared. So if I subtract a squared, those are going to cancel each other off. I get a b squared right here. And then on this side, I'm going to go ahead and write it as c squared minus a squared, just because I don't want that negative starting that off. Besides that, we know what these formulas represent for a squared plus b squared equals c squared, just the Pythagorean theorem. Okay? I've got the term with b on one side by itself, but it's not completely by itself. It's not isolated. It's not all alone. I need to get rid of that square. D, what do you think? Take the square root. So I'm going to take the square root of this side and the square root of that side, the entire side. So that's going to take a long square root to encompass the whole thing. These two undo each other, so I'm going to get b equals the square root of c squared minus a squared. They're not like terms. We don't know what numbers they are or anything like that. So it just gets to sit there. Okay. Does anybody notice anything slightly wrong with this that we ought to pick up on? Andy. Should have a plus or minus.
That's what I was going to say.
Okay? Should have a plus or minus, because when we put a square root in a problem, we want to put a plus or minus in there to account for it. Now, let's talk for just a second. What's this formula about? Luke.
I've got a question.
Sure.
Couldn't you take the square root of a and b and c beforehand and then have b equals c minus a?
Great question. Let's try a numeric example. So the question is this. If I've got a squared plus b squared equals c squared, could I take the square root of all of these and get something that's much easier to work with? Let's check. Does everybody agree 3 squared plus 4 squared equals 5 squared? What's the square root of 3 squared? Square root of 3 squared would be 3. Square root of 4 squared would be 4. Square root of 5 squared would be 5. So this would say 3 plus 4 equals 5, does it? Okay. Square roots don't mix well with addition or subtraction. They mix well with multiplication and division. Okay. So you can't take the square. You have to take the square root of the entire side. Okay. So it won't work that way. Everybody good? It's a great question. Back to my original question. What is this formula right here? What is it about? I mentioned it earlier. Lizzie. It's the Pythagorean theorem. What is the Pythagorean theorem about? Right triangle. Right triangle. These are about the sides of a triangle. Could B be negative? If this is truly the Pythagorean theorem, B can't be negative, so it would just be B equals the square root of c squared minus a squared. It would just be this. So I'm going to put a dotted circle around that. Let's say in some strange universe, A, B, and C represented some quantities that could be negative. This is a real world problem if it's the Pythagorean theorem, and real world triangles do not have negative lengths. So this would not be a plus or minus, it would just be the plus one. Okay? Does anybody recognize that formula? It's the volume of a cone. Very good. Volume of a cone. So these should all be positive values. So as we're going through and we're solving this for r, we're going to get the r completely by itself. So a couple of quick things that we can take care of. One thing we normally don't like to work with is denominators. So the first thing I'm going to do is I'm going to multiply both sides by 3. That's going to cancel off, and I'm going to get 3v equals pi r squared h. Now, you can do this in fewer steps, but that makes it look a little bit cleaner. As far as we're concerned, this is a number. We know pi is a number, and h is a number. R is the variable we're trying to get by itself. So I want to get rid of the pi and the h. Can somebody raise their hand and tell us how we're going to get rid of the pi and the h? Samara? Yeah, we're going to divide. And I'm going to do them both at the same time. So I'm going to divide by the pi and the h. Those are going to cancel. So I end up with r squared equals 3v over pi h. And then I take the square root. Now, if we know this is the formula for the volume of a cone, do we need the plus or minus? No. Okay. So I'm going to write r equals, I'll write the plus or minus right here. If we get some numbers for this, that's what we'd plug into our calculator. But the thing I'm going to circle and say, hey, I think this is my answer, is this guy. Okay? Any questions? We good? Okay. Gets really interesting now.
Wouldn't you want to get rid of the radical on the bottom? Or are we just not gonna...
Not on this. We're just going to get, it just said get the b by itself. Besides, if we get numbers, we'd probably just plug it in and have our calculator spit out the answer. Okay? All right. What's the only variable as far as we're concerned? K. K is the only variable. So I'm going to zoom in on this, and we want to get k by itself. So the first thing I'm going to do is I'm going to get rid of the 2 because I don't want to work with that denominator. So we'll multiply both sides by 2. So this is 2n equals, and this cleans up nicely, k squared minus 3k. Now, here's the issue. Both the ones that we've solved so far as we're concerned, they're quadratics because we're solving for a squared variable. We've got a k squared in here, so this is a quadratic. So the first two, we solved using a particular technique of solving quadratics. We have 4 of them. What are the 4 techniques for solving a quadratic? Well, give me one. Quadratic formula. What's another one, D? Completing the square. What's another one? Square root. And last one? Go ahead. Factory. Okay, so we got 4 of them. Square roots, completing the square, factoring, and quadratic formula. Which technique did we use on the first 2? We took a square root. All we had to do was undo squaring. We got it by itself. We undid the squaring by taking the square root. Can we do that on this one? Nope. So what do you want to use? Our 2 favorite techniques are factoring, but do you think that factors?
No.
Quadratic formula. So to use the quadratic formula, it has to be set equal to 0. So the first thing I'm going to do is I'm going to move the 2n to the other side. So here's what I've got. 0 equals k squared minus 3k minus 2n. Okay, watch carefully. There's A, there's B, and there's C. Now the cool thing about this is we just plug into the quadratic formula. So on your paper somewhere, would you write the quadratic formula? Not right here. Somewhere else, would you write down the quadratic formula? Oh, sorry. I've got an arrow right here. It's the whole thing. It's the whole thing. Sorry about the arrow. write the quadratic formula somewhere. Not right here. Just write the quadratic formula. The regular old quadratic formula with the A's, the B's, the C's, all that sort of stuff. You may have memorized it with a song or something. However you got it memorized, you got to have it memorized.
Just marking it.
Okay, that's enough time to write it down. Here we go. So in this case, it's not x equals, it's going to be k equals. Negative b or opposite b, so that's going to be a 3, plus or minus a big square root, b squared, which is 9, and then I always write down this part, minus 4 times a times c. So this is going to be a k, or sorry, this is going to be a 1, because that's an a, and then this is negative 2n, and then on the bottom is 2 times 1. So if we start simplifying this, this is plus or minus here, 9, and a negative times a negative is a positive. So that's going to be plus 8n, and the bottom is a 2.
So that's okay. So we should solve for k. Let's go. We
Is
did it.
k on one side all by itself?
Yes.
Yep. Done. That's it. So just like before, let me go full screen on this so you can see both sides of this. The only variable in the first problem is b. If they told us a and c, would we get a number answer on this side? Yep. For this one, the only variable on part b was just the r. If they told us what v and h are, could we plug this in our calculator and get a number? Yep. If we take a look at this last one, so here it says k equals 3 plus or minus a big square root, 9 plus 8n over 2. If you look at the original problem, the only variable as far as we're concerned is k. The only thing missing is an n. If they gave us a number for n, could we figure out a number for the answer?
Yes.
And would we get 2 answers because there's a plus or minus? We would. And we don't have to worry about, real world problem or anything like that. Let's do 2 more and then we'll turn you loose on the assignment. Yeah.
On C, could we simplify it further and take a 3 out?
Great question. Great question. Can you take a 3 out of here? Okay, watch. This goes back to the same thing Luke brought up. Do square roots play well with addition or subtraction?
No.
They don't. Okay, so you would have to factor something out. You'd have to make this a multiplication problem in order to do that. That's a great question, though. Okay, so I want you to take a look at D. I'm not quite sure what this formula is. We don't have to know. We just have to get R by itself. Lizzie, what do you want to get rid of first? Perfect. So we call that A naught. Okay. So we're going to divide by A naught because those are just numbers. We can do that. Those are going to cancel. So I have A over A naught, and I have 1 minus R quantity squared. Crew's arm nearly came out of socket. Crew?
Do that.
And what's
Square root it.
there we go. Oh, square root it. He's going to use that terminology. We're going to take the square root of both sides. So we get the square root of A over A naught equals 1 minus R, which is good. Now we can see the R. It's not in parentheses or anything. Do we need a plus or minus on this one? Without more background information, we probably ought to put a plus or minus on there. Without knowing what A and A naught are, I think this is something to do with compound interest or something, but if we're not sure, we're not going to do anything with that. Now all we have to do is move the 1 to the other side. So we're going to subtract 1. So this is negative 1 plus or minus, and this is an interesting one. So we have A over A naught equals negative R. What do we do? Divide by a negative. Now, listen very carefully. We're going to divide everything by a negative. So that gives us an R right here. What's negative 1 divided by negative 1? 1. This stuff looks exactly the same as it did before. What goes in front? Still a plus or minus. It doesn't mess with that at all. Because we've got a positive divided by a negative, that's going to give us a negative. A negative divided by a negative, it's still going to be a plus or minus either way. And there's the answer. Okay? Any questions?
No.
Okay. I'll give you a 30-second head start on this one.
What?
You're right. Thank you very much. Don't say anything. Get a start on that one. I'm going to call on somebody in about 20 seconds. You don't have to get the answer right, but just give us a good first step or a good guess at the first step. Gavin Bean, good shot at the first step here. They are, so could we take a square root of this, a square root of this, and a square root of that? Andy's shaking his head no. Andy's right. A couple other people are shaking their head no. Andy, I've already said this twice today. Do square roots play well with addition or subtraction? They don't, so you cannot do that. Mason.
Move the x over to the other side. Then plus 1 is
Okay, here's the term with y squared in it. Let's start by getting that by itself. So Mason's right. Mason, how do you move this x plus 1 quantity squared over?
subtract by x plus 1.
Yeah, we think of this as one entire thing. Right now it's positive, so we're going to subtract x plus 1 quantity squared from both sides. So subtract x plus 1 quantity squared from both sides. Here's what we've got. We've got y minus 3 quantity squared. And I'm going to go ahead and write r because it's positive. I just kind of like that coming first. And then x plus 1 quantity squared there. Now what do we do, Zach? Now we're going to take the square root. We've got to uncover that y. We've got to get it out of the parentheses. We've got to get it out of the square. So this is going to be y minus 3 equals, do I need a plus or minus here? I do. Plus or minus big square root, r squared minus x minus or plus 1 quantity squared. All that has to stay under there. It would be super cool and it would really simplify things if you could just say, hey, the squares cancel with the square root. Okay, doesn't work that way. Radicals do not play well with addition or subtraction. So the last step we need to do is just add 3 to both sides. And this will look kind of familiar. Y equals 3 plus or minus a big ugly square root thing. That's it. Okay. Now, here's the cool part about this. Mason said a second ago what shape that is if you graph it. The cool thing about this is your calculator can't graph the original version of that. But can your calculator graph a y equals?
Yeah.
It can. How many y equals do we have there?
1.
How many answers do we have?
2.
We have 2.
Oh.
So if you were to type that into your calculator as 2 different equations, hang on. If you,
Yeah, why did we
oh,
practice
sorry.
that?
Oh, pass that back up. Pass that back up.
Pass what?
Yeah, pass that back up.
Yeah, my bad. Let me just keep
Oh,
that.
I may or may not have put
May or may not
Really?
have actually on that. Okay, I apologize. I was on autopilot. Okay, back to this problem here. You could have y equals the 3 plus the stuff in the square root, and you could have y equals 3 minus the stuff in the square root. Somebody said, well, how do you plug in r? Okay, you pick a number for that, okay? That's going to be a number. So if you wanted to say put a 5 in there, you're going to get a certain shape. If you want to mess around with that, you're welcome to.
The 5, does that just stretch it?
How do you do a plus or minus?
You have to put it in as 2 separate ones. So on y1, put the plus, and on y2, put the minus.
Would the R just stretch it?
You're on the right track. You're on the right track. Try a couple different R's.
Yeah.
You don't want to.